for example 7, we're going to be finding zeros of quadratic functions, and you can either have two zeros, like in the first picture here. You could have 1 0, like the second picture, or you could have no zeros at all. Zeros are the places where your graph is going to be crossing over the x-axis, so you can call those x-intercepts. And they are also the places on the graph where y is equal to 0. So when you solve a quadratic function for its zeros, you're basically going to be working backwards and finding your x-intercept by letting y equal 0. So in this problem right here, you would have two answers where y is equal to 0, two ordered pairs where y is equal to 0. In this problem here, you would have one ordered pair where y is equal to 0, and then the last one you wouldn't have any at all. Okay, so I'm going to go down here to example 7a, and I'm going to plug in a 0 for my y value. Remember, the f of x is just your y variable. So a 0 is going to go in for f of x, and then we're going to go ahead and solve for x. And then I have a situation where I don't have a constant term. Standard form of a quadratic is ax squared plus bx plus c equals 0, and I am missing that constant term on the end. So I'm going to take out a greatest common factor to solve this. I'm actually going to just rewrite my equation so the 0 is on the right side, and you don't have to do that. It's kind of an extra step that's a little bit of a waste, but I just want to write it that way. So I'm going to take out a 2, and I'm going to take out an x because that is the common factor in between the two terms. And when I take out a 2x, I'm left with x minus 2. And you can go ahead and mental math that through and see if you factored correctly. Just do a double check that you get 2x squared minus 4x, and I do. And then we are going to use the zero product property that looks like this. If a times b equals 0, then a must equal 0, or b must equal 0, one or the other. So I'm going to take my first factor and I'm going to set it equal to 0. I'm going to take my second factor and set it equal to 0. And then we can go ahead and solve. If you divide by 2, you get x equals 0. And if I add 2, I get x is equal to 2. So if I were to graph this function and I made a whole entire xy table and I graphed a whole bunch of points, I know that 2 of those points would look like this. I would have a 0 right here at x equals 0, and I would have a 0 over right here at x equal 2. My parabola has a positive x squared term, so it's going to open up. The graph will open upward, and it'll look something like that. Okay, so when you're solving a quadratic function for its zeros, you're finding the x-intercepts where y is equal to 0. Okay, so let's go ahead and solve the next one. Once again, we're finding our x-intercept where y is equal to 0. Remember, your f of x is really just your y, so we're going to put the 0 in for f of x. And then I'm going to flip, no I'm not, I'm going to leave it just like it is because I notice that I am missing my b term, my bx term here in the middle. So since I do not have an x term and I have my x squared term and my constant, I am going to solve with the square root method. When you are missing your middle term, you will solve with the square root method. All right, so I'm going to add my 10x squared to the other side. And I get 10x squared is equal to 10. And then I'm going to divide both sides by 10. And now I have isolated my x squared. On the right side, 10 divided by 10 is 1, and then we can take the square root of both sides. Don't forget to put your plus or minus in front of your square root symbol, and then x will equal plus or minus 1 because the square root of 1 is 1. Now, if I were to graph this function and its curve, then I know at -1 and +1, I would have some zeros there, the x-intercepts. And my graph has a negative in front of the x squared term, which means the graph would open downward. So it would be a parabola upside down, and that's what a basic sketch would look like of that graph. So the zeros of your function, the solutions are going to be those x-intercepts where y is equal to 0. Okay, let's go ahead and solve the next one. For C, I'm going to start the problem exactly the same. I am going to let my f of x or y equal 0. I'm going to sub in a 0 for f of x or y. And I'm going to go ahead and set up 2 sets of parentheses so that we can go ahead and factor this trinomial into 2 binomials. If it wouldn't factor and you were stuck here for a long time trying to factor, then you would go ahead and use the quadratic formula, or you could try to complete the square if it had good conditions for that. So I know this one factors because obviously I have the answer key, and I just want to have an example in here of showing you how to factor. So if you have all 3 terms, you have your ax squared, your bx, and your c, you're going to try to factor. If you can't factor, or you just kind of get stuck at some point, even if it is factorable, then you can switch to the quadratic formula. You just don't want to always go to the quadratic formula because it takes a lot of time to do, and factoring is much faster. Okay, so we need factors of 2x squared in the first position of each binomial. 2x times x gives me 2x squared. Then we will have factors of our last term, 15, in last position of each binomial. And so I'm going to have either a 15 and a 1, or a 1 and a 15, or a 3 and a 5, or a 5 and a 3. And so you're going to go ahead and put some kind of test factors in there if you're not sure which one's going to work, and this is how you're going to figure out which factors you should put in for 15. You will multiply the inside 2 terms here. If I were to FOIL this and FOIL this out, we're going to multiply the inside terms, the I terms in FOIL, and that would give us 3x. Then you're going to multiply the outer terms. Okay, so this is my outer terms, my FO terms, my FOIL, my O terms are out here, and that would give me 10x. And can you make a combination of the 10x and the 3x to give you -13? And the answer is yes. If this was negative and this was negative, I would get -13x. And so this 3 would need a negative, this 5 would need a negative, and you just want to double check that if you multiply -3 times -5, you do get +15, and you do. So this is the correct factorization. My f in FOIL gives me 2x squared, I already know that. My L in FOIL gives me +15, I already know I'm going to get 15 because I chose factors of 15. Your job is to make sure that your O and I, your outers and your inners combine back up to give you the original middle term. And they do now. So let me just get rid of this because it's kind of in my way. So this is a minus and this is a minus, and we're good. And then I'm going to take each factor and I'm going to set my factors separately equal to 0 to finish solving. That's called the zero product property. And then to solve this first little mini equation here, I'm going to add 3 and then divide by 2. And this guy over here, we're just going to add 5, and those are your 2 zeros. And if I were to go ahead and show you just a little quick sketch of this graph, over at 3/2 or 1.5, I would have a 0. Over at +5, I would have a 0. And it looks like our graph is opening up because it's positive x squared term. And then our graph would look something like that. All right, so let's go ahead and do D. Okay, so for D, I see that I have the whole trinomial, and I would try to factor this. And after struggling for a little bit, I would figure out that this guy is not going to be factorable. So we could either do completing the square, or we can do the quadratic formula. Now, you don't always know right away if you're going to be able to factor it, so you're going to have to like try it out. And before I get started doing the problem, let's go ahead and do what we need to do for every single one of these functions, and we have to let our y value equal 0. So when we solve a function, we're going to be looking for the x-intercepts where your y value right here is set equal to 0. And then you can go ahead and reduce this entire equation by 2. What you do to one side, you do to the other, and it's keeping that equation balanced. So I can divide the entire equation by 2. And I get 0 is equal to 4x squared minus 4x minus 5. And you can just leave it alone the way it started if you wanted to. You didn't have to reduce the whole equation by 2, but since you can, I'm going to do it. And that just makes the numbers smaller. When we do the quadratic formula, which we're going to have to do, then it's just going to make the calculations a little bit easier. If you did just use the 8, 8, and the 10, then you would still get the same answer in the end. You just would have to make sure that you like handled the bigger numbers properly and you were careful. Okay, so I would fool around with this for a little bit and see if I could factor it, and eventually I would realize that I can't factor it and get stuck. And so then I'm going to either use quadratic formula or completing the square. To complete the square, you need to have your first term here, your x squared term. You would need to have a 1 as the coefficient, so you would have to divide by 4. And if I were to divide my entire function by 4, then I would have a whole number, and here on the end, I would have a fraction. And I don't like to complete the square on problems that have fractions. So it's going to get a little too messy for my taste, so I'm going to stick to the quadratic formula. And when you use the quadratic formula, you have to move everything to one side and set the problem equal to 0. Move all your x terms over, and they already are. So we're ready to go ahead and pick off our a, b, and our c. The a is going to be 4, the b is going to be -4, and c is going to be -5. Now, if you do not divide your entire equation by a common factor like we did above here, and you leave everything kind of unreduced, it doesn't really matter. You're still going to get the same answer in the end. Like I said, the calculations are just going to be a little bit bigger. The numbers are going to be bigger. All right, so let's go ahead and plug into the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and you can sing a little song in your head if you want to. I kind of was singing it a little bit mentally as I filled in my numbers, and then we'll clean it up. I get a positive for my first term here, plus or minus the square root of 4 squared is 16, and 4 times 5 is 20, and 20 times 4 is 80, and you have a negative times negative, which will be a positive, and And so on the bottom you get 2 times 4, which is 8. On the top you get 4 plus or minus the square root of 96 all over 8. And that will equal 4 plus or minus. Now 96 can be factored into, I believe, 16 times 6. And since you can factor 96 into two factors where one is a perfect square, then you absolutely need to do that. And then you end up with 4 plus or minus 4 root 6 all over 8. And you will factor out a 4 in the numerator, and you're left with 1 plus or minus the square root of 6 all over 8. And finally, you can reduce the 4 and the 8, and your final answer is 1 plus or minus root 6 all over 2. And then I would leave the answer just like that. You can split this problem up into two separate fractions if you want to, but I prefer the answer to stay like that. All right. The last problem right here, once again, it's a trinomial. You would try to factor it first, and if it didn't factor and you got stuck, then you can do the quadratic formula or complete the square if conditions are right. So I'm going to first substitute in a 0 for my y. F of x is really y, and we're trying to find the x-intercepts or the zeros of that function. So we need to let y equal 0. And then I'm going to go ahead and divide my entire equation by 2, because 2 is a common factor straight through the whole entire thing. So as long as you divide your entire equation by the same number all the way straight across, then you keep your equation balanced, and it's a legal move. Okay, so I get x squared minus 8x minus 2. This is the perfect candidate for completing the square. I cannot factor it, so I'm going to have to use either quadratic formula or completing the square. Perfect candidate for completing the square. And the reason is because the coefficient in front of your x squared term is a 1, and your middle term, your b term, your bx term is even. So when I complete the square on it, this 8 is going to divide in half nicely. Okay, so for completing the square, you need to isolate your x terms and get them to one side. So we'll add 2 to both sides. So I'm going to add 2 to this side, and I'm going to add 2 to that side. It's going to move it to the other side. And I'm going to write my x squared minus 8x on the left now, and then I'm going to write that 2 on the right side. I'm just going to swap the equation around. The next step when you complete the square is to add b over 2 squared to both sides. And I usually just figure that out in the margin somewhere because it makes my work down here too messy, I feel, if I do this right where I'm working. So off to the side, I'm going to do b over 2 squared, and you get negative 4 squared, which is 16, and then that's the amount I'm going to add to both sides. So I now have x squared minus 8x plus 16 is equal to 2 plus 16. That makes a beautiful perfect square trinomial on the left side, and on the right side we get 18 when we combine. This is going to factor into x and x, and negative 4 times negative 4 adds multiplies to 16 but adds to negative 8. And now that you have your binomial twins over here, you're going to write those condensed as x minus 4 squared. On the right side, you still have your 18. And then once you have your perfect square trinomial factored into twins and condensed exponentially, you can square root both sides. I will be square rooting the quantity x minus 4 squared. What you do to one side, you do to the other. Make sure you put a plus or minus in front of your root symbol. On the left side, the square root cancels out the exponent of 2 and the x minus 4 is released. On the right side, we are going to be breaking down root 18 into 9 times 2. The square root of 9 will become 3 and the root 2 will stay behind. And lastly, we're going to add 4 to both sides, and I'm going to squeeze that 4 in front of the plus or minus. So we end up with 4 plus or minus 3 root 2, and then we can box that off as our final answer. You do not have to split it into 2 separate answers. The 2 separate answers would be 4 plus 3 root 2 and 4 minus 3 root 2, but you can leave it alone just like this. Now F is the last problem here, and you are going to need your graphing calculator to do that. So I'm going to open up my graphing calculator and I'm going to go ahead and type in my equation. Negative 2x squared plus 13.4x minus 5.7. This decimal of a problem is not going to be factored. You can try to do the quadratic formula, but I really would not want to work with those numbers. So entering it into the graphing calculator is the most efficient, convenient way to do the problem. And I'm going to go ahead and graph it and see what the graph looks like. It would be nice if it fits in the window, and it does. You can zoom into this a little bit more if you want to. I'm going to leave it alone, and I think I can handle it with this window. We're looking for this guy right here where my cursor is pointing at. We're looking for that 0, and we're looking for this guy right here on the other side, looking for that 0 as well. You are finding the x-intercepts or the zeros of your function when you solve it. So I'm going to hit second trace, which gives me the calculate window. And then we are going to hit type in 2 for our 0 feature. And then I see that it wants a left bound. So I'm going to scoot up to the left side of that 0 as close as I can get. I'm not really sure if I can go this far. I think I can, but I'm just going to play it safe and move my cursor here. And then I'm going to set that left bound. Then I'm going to go above the x-axis a little bit more to the right to get my right bound. So I just bumped over the x-axis, moved over to the other side of that 0, and then I'm going to hit my right bound. And then finally, my calculator wants me to guess, and I think that's as close as I'm going to get to the actual 0 or x-intercept. And then I hit enter, and I get 0.456. So 0.456. So x, see if my pen cooperates. X is equal to 0.456, and I also have another 0 there. So I'm going to once again do second trace, which is going to take me in the calculate window, then 2 for 0, and now I'm going to scoot over, moving to my other 0. Okay, so the calculator is asking me for the left bound, and this would be considered the left side of my 0 on top of the x-axis. They're above the x-axis. That's more to the left on my graph. So I'm going to set that point and hit enter. Then I'm going to go to the right bound of that particular 0. So a little more to the right. I'm on the right side of that 0, and then I'll set that with an enter. And then it's asking me to guess exactly where that 0 is, and I think that is the closest I can get to my actual 0, and I will hit enter, and there it is. And my x value is 6.244. So we have, what? So we have, see if I can get this down. Nope. I'll just write it over here. X, nope, I won't. X is equal to 6.244, I think it was, and then we'll just forget about that right there.